Now, just as you can create file, local, or module variables by defining a variable outside of any function but declaring it static, you can do the same kind of thing with top-level functions. That is, you can have static top-level functions which are only accessible to the code inside of one particular file, as opposed to being accessible to all of the code in your entire program. Alright, so you can think of these as being like file local functions or module functions. Now, you probably recall that when we developed our binary tree class, we had a whole bunch of top-level helper functions that did the low-level hard work of messing around with the nodes in our binary tree. Ideally, we would like users of our binary tree class to have to use the class interface functions, that is, the class member functions, when they create and interact with binary tree objects. And we would like to make it impossible for application developers or other programs to directly make use of these helper functions. We can do that, as illustrated here on slide 9, by putting the word static in front of the declaration and or definition of a helper function. Okay, so here we have a class member function, the put class member function, that displays the binary tree onto the screen. It does this by calling a helper function named putBinaryTree, passing in the top of the tree, that is a pointer to the topmost node of the tree, as the argument to the helper function. If we declare the helper function static, then the helper function can only be used by the functions within this source code file. In this case, this is our binarytree.cpp implementation code file for our binary tree class. Okay, so this is a very common technique for defining functions that can be accessed by other functions in the same file, but that cannot be accessed by other functions outside of this file in other parts of the program.